Another thing that we want to do is look at overloading the stream insertion and stream extraction operators. So, as you know, if you want to read a string in from the keyboard, then you can write something like this. So if I have a person's name, I can read it from the keyboard like that. And of course you can read multiple things at a given time. We saw this in the implementation of the time class, where you can read hours, then you can read a character, and then you can read minutes. And of course what I'm doing here is, first of all, I'm cascading these extractions, and I'm extracting different things. So here this operator is extracting an int, and this operator is extracting a character, and of course this one is extracting another integer. What I really want to be able to do is, just for uniformity, if I can read strings like this, if I can read integers and characters, how can I read a time object? And so what I need to do is I need to implement an operator, an extraction operator, that will extract time, a time object. Similarly, for cout, as you know, we can print out hours, and then we can print out a character, we can print out another integer. And of course we can use the stream modifier to give us an end of line. And what's happening here is this is inserting an integer. This is inserting a character. This is inserting another integer, and this is inserting the end of line. What if I want to use the stream insertion operator for a time object? How can I do that? Or multiple time objects. So to do that, like overloading the equality and the plus equals operator, we can overload the stream extraction and stream insertion operators, although we do this using a very different mechanism with operator equal and plus equals and less than. So these could be, methods of the time class. This actually can't be a method of the time class because, first of all, we're using an input stream and an output stream here. So what we do is we overload this we overload this operator as a function, and then we make it a friend function. So we could, and what a friend function does, so friend functions can access an object's private data members. Okay, so now there's some controversy about friend functions. We just spent all this time putting data members in the private section, implementing a public interface, and now with the use of one keyword, friend, we're now going to give these functions access to the private data members. So there's a little bit of controversy about whether the notion of friendship is a good idea, and you can decide. You can certainly implement these functions by using the get and set methods, but we're using friend functions first of all so you can learn about them. There's also the notion of a friend class, and again, you can define a class that has access to an object's private data members. so you can avoid going through the public interface. But we're doing it for efficiency so that we can just refer directly to the private data members, and we can avoid going through, in some cases, the get methods. We're still going to use the set methods just because we want to make sure that we apply our data integrity checks. So let's unwind this a little bit and try to understand what function we actually need to implement. So if you write cin time, just like that. First of all, this is an input stream, an I stream. And of course, we're going to be changing it. We're changing it because we're going to be extracting a time object. And of course, this is a time object. And we're going to be changing it too, because whatever values it has for hours and minutes, we're going to be replacing them with the values that we read out of the input stream cin. And as far as this operator goes, the same rules apply. If I want to implement a routine for this operator, what I need to implement is operator followed by the operator itself. Except now I'm not going to be implementing this as a method, I'm going to be implementing this as a function. And the first argument is the input stream, which of course is called an I stream. So the first parameter to this function is an I stream, and since I'm going to be changing it, I have to pass it in by reference, and I'm just going to name the parameter in, because it could be a console input. It could also, I'm going to be able to use this for a file as well. And this is going to be my second parameter to this function. Of course, it is a time object, and I want to pass this in as a constant. Oh, I'm sorry. I actually don't want to apply, pass it in as a constant reference. I can't pass it in as a constant reference because I've got to change it. I'm just going to pass it in as a reference to a time object, just like that. So that's the function that I want to implement. Similarly, one more little point here. I want to be able to cascade these extractions, right? I'm going to read out a time object, but then there could be other extractions that I need to make. So after this operator extracts a time object from the iStream in, then it is going to pass it along to the next extraction operator. So the return type for this function is also going to be a reference to an iStream. Just like that. And the way this ends up getting, getting interpreted in the program is, this is the first operation that I perform. Well, that's a call to operator passing in cin and passing in the object time. So this is going to extract a time object from cin. Well, whatever this return value is, that is going to be the input to this extraction. And in fact, it's going to be the first argument to a second call to the extraction operator, and we're going to extract time 2. And this operator is going to return the modified string after it's extracted time 2, and that will be input as a parameter to the third call, just like this. And that will extract str, which I'm kind of assuming is a string here. So this is how we get these cascaded extractions, is we do this, and then this is input. Whatever the modified stream is, it's input to this extraction operation, and whatever the modified stream is after that, it gets input into this one. And so it looks something like this, and this is how we achieve it. Our first parameter is the stream. We extract a time object, and then we return the modified stream here, as you'll see. You'll see in the implementation. So this is kind of the key point here. This is the prototype for the function that we want to implement when we overload the extraction operator. Now, very similarly, we're going to do the same thing for cout. So when we cout, maybe we input our output a string, and then we have some time object, and maybe we have some other things, right? Well, if we look at just this one simple example, right, here's my operator. So I want to implement a function called operator with the little extraction operator. The first argument is going to be cout, which is an output stream. I'm going to be changing it because I'm going to be inserting a time object into the output stream. So I need to pass that by reference. And the time object is going to be the second parameter, but I'm not changing that. So here's where I can actually pass this in as a constant reference to a parameter. Just like that. And because I want to do these cascaded insertions, I need to return here a reference to the modified output stream. So this call is going to insert the string literal. So you're going to get something like this call to this method with cout and this string constant or literal. This operator is going to insert that into the output stream cout. That modified stream will be the return value of this call. That will go in as the first parameter to the next call, which we will pass in as the time argument here, and so on and so forth. But this is the prototype of the function that we want to implement. So how do we put this into our class?